Good morning and welcome to Poem Physics 365, physics every single day of the year. Physics past, present, and future. The podcast doors are closing.
Alright, hello and welcome to today's edition of Poem Physics 365, physics every single day of the year. And today, on Tuesday, the 19th of January, 2016, let's take a look. On this day in physics, 19th of January 2014. The first secure quantum computer has been made by combining entanglement, a bizarre property of tiny particles, with the power of apparent randomness. This technique is similar to quantum cryptography, which guarantees the secrecy of a message sent from one place to another, but in this instance guarantees that privacy of data processing. It could enable code breakers, governments, and private individuals to harness the power of quantum server remotely without having to worry that the owner can snoop on their data or calculations. So that happened just 2 years ago. We had the first secure quantum computer created, but I would imagine probably not going to get your hands on that anytime in the near future. But that brings us to our word of the day. We heard it mentioned several times in the on this day in physics. The word is entanglement. And so what is that? Quantum entanglement is a phenomenon which occurs when two or more particles are related in such a way that they cannot be described on their own, but rather as an entire system. Example: there is a highly famous paradox regarding entanglement. It's known as the EPR paradox, named after its creators Einstein, Podolsky, and Rosen. They had this idea that if you had a particle which had a spin of 0, which decayed into two separate bodies, each one would need to have a spin of opposite and equal amount, say 1/2 and -1/2. Both would need to add up to the original particle's spin of 0. Now these particles during the decay would be traveling in opposite directions, existing in a superposition of states, being both 1/2 and -1/2 at the same time. And these particles would not have a definite spin until they are measured. Now imagine that these particles traveled in opposite directions to the end of the known universe. One of these particles is traveling and waiting for you to measure it at one end of the universe. When you measure its spin, the superposition of states collapses, and you find out that its state is +1/2. On the other end of the universe, the other particle's state immediately collapses to -1/2 spin and will never change its state. Now, as these particles are entangled, they are related in such a way that when one state collapses, the other does so immediately. This is alarming because there is a speed limit at which information can be transmitted, which is the speed of light, or 3 × 10⁸ meters per second. However, quantum mechanics can experimentally verify this as being the truth of nature. Entangled particles exist, and we are learning to make use of them on small scales to do extraordinarily fast and secure computing. So that is entanglement. Very, very, very cool concept. So let's go into the third segment of the podcast, the killer resource. Something from the Poem Physics podcast, this older blog entry called 8 Hot Tips to Pwn Next Semester. Since we are on the heels of a new semester, this older blog entry from the website comes equipped with a printable PDF of 8 Hot Tips to Pwn Next Semester. Something to hang above your bed and think about as you drift off into slumber with dreams of physics dancing in your heads. So there we go, a very cool kind of quantum episode of Poem Physics 365. And I think that's going to do it for today, guys. So until tomorrow, I'll be here in the physics zone. So I'll see you next time, guys. See you tomorrow. Take care.
The pod bay doors are reopening. You may now resume normal life functions.